So next example is solve this assignment problem. We observe that the cost matrix is not a square matrix, so it is an unbalanced assignment problem. Here the cost matrix is not a square matrix. So it is an unbalanced assignment problem. Therefore, it is an unbalanced assignment problem. So we have to first make it convert it to a balanced assignment problem by adding one dummy row to the cost matrix. So we first convert it to a balanced assignment problem by adding a dummy row fourth row, dummy row say D, with zero cost of assignment. We get following balanced assignment problem. So all the entries will remain as it is, only we have to add one more row to the cost matrix with zero cost of assignment. So let us add a dummy row D with zero cost of assignment. And other cost entries we keep as it is. Other entries in the cost matrix we keep as it is. So first row as it is, second row as it is, third row as it is, so this is a balanced assignment problem on which we apply usual method, that is Hungarian method or Hungarian technique to get optimum assignment. So what is the first step? Subtract minimum element of each row from all the entries in that row. So what is the smallest entry in the first row? 18 is the smallest entry in the first row. So subtract 18 from all the numbers in the first row, we get So let us subtract 18 from all the entries in the first row. So 18 minus 18, we get 0. 24 minus 18, we get 6. 28 minus 18, we get 10. Then 32 minus 18 is 14. Now, smallest element in the second row is 8. Subtracting 8 from all the entries in second column, we get, sorry, from all the entries in second row, we get 8 minus 8, 0, 13 minus 8, 5, 17 minus 8, 9, 19 minus 8, 11. Now smallest entry in the third row is 10. Subtracting 10, we get 10 minus 10 equal to 0. 15 minus 10 is 5. 19 minus 10 is 9. 22 minus 10 is 12. And smallest element in the fourth row is 0. So subtracting 0 will not change the entries in the fourth row. Now let us apply step 2. Repeat step 1 for columns. Same procedure for columns now. Now if you look at the column number 1, what is the smallest entry? Smallest number is 0, so subtracting 0 will not change the numbers of column 1. Similarly, column second contains smallest number 0, subtracting 0 will not change this column. Then column number 3, smallest number is 0, subtracting 0 from all the numbers in column 3 will not change the third column. Similarly, fourth column, smallest entry is 0, so it will not change the elements of the fourth column. So second step will not change the elements. So next we will apply step number 3. Cover all zeros with minimum number of horizontal and vertical lines. So let us apply step number 3. Cover, because step number 2 does not change the cost matrix. Let us apply step number 3. Cover all zeros with minimum number of horizontal and vertical lines. So starting from the first row, look at the rows containing single zero. First row contains single zero, so we make an assignment here and we draw a vertical line. When we make an assignment in a row, we have to draw a vertical line. Then second row does not contain single zero. Third row does not contain single zero. Fourth row does not contain single zero. Now consider column. First column, an assignment is already made. In the second column, there is a single zero in the second column. So we will make an assignment here and we draw a horizontal line. So all zeros are covered with these two lines. So we have drawn minimum number of lines. The number of lines are 2 and the order of the matrix is 4. So this is not an optimum solution. So number of lines, we observe that number of lines horizontal and vertical lines are 2. and it is not equal to order of the matrix. Order of the matrix is 4. So two are different. So this is not an optimum solution. So we apply step number 4. So what is step number 4? We required smallest uncovered number. Now look at the uncovered number: 6, 5, 5, 10, 9, 9, 14, 11, 12. 5 is the smallest uncovered number. So we have to subtract this uncovered number, smallest uncovered number, from all these uncovered numbers, add it on the intersection. We will add it here on the intersection, and other numbers on the line will not change. So let us apply step number 4 with this smallest uncovered number 5. So let us apply step number 4. Subtract the smallest uncovered number in the matrix, which is 5, from all the uncovered numbers. Then add the same number to the numbers which are on the intersection of horizontal and vertical line. And do not change other numbers. So first column, 0, 0, 0, these are the 3 numbers on the line. Do not change these numbers because these are not uncovered numbers. And on the intersection we add 5. So 0, 0, 0, 5. These are the numbers in the first column. 0, 0, 0, 5. Now let us find the numbers in the second column. Now 6 is the uncovered number. 5 and 5 are uncovered numbers. So we have to subtract 5. 6 minus 5 is 1. 5 minus 5 is 0. 5 minus 5 is 0. So 1, 0, 0. And we will keep this 0 as it is. So subtract 5. So 6 minus 5 is 1. 5 minus 5 is 0. 5 minus 5 is 0. And 0 as it is. So 1, 0, 0, 0. 1, 0, 0, and 0. Then third row, subtract 5. 10 minus 5 is 10 minus 5 is 5. 9 minus 5 is 4. So we get 5, 4, 4, 0. 5, 4, 4, 0. Third column. Then last column, fourth column. (14 minus 5) we get 9. 11 minus 5 we get 6. So 9 and 6. And other two numbers are 12 minus 5, 7 and 0 as it is. 7 and 0. So we have applied step number 4 to the cost matrix obtained in step number 3. Alright. So after applying step number 4, we have to apply step number 3 again. Apply step number 3 again. So after applying step 4, we have to apply step 3 again. So cover all zeros with minimum number of horizontal and vertical. Look at the rows containing single zero. First row contains single zero. So we make an assignment here and we draw a horizontal line. In the second row, there is a single zero because first zero is already crossed. So this is a single zero left. So make an assignment here and draw a vertical line. Then third row does not contain single zero. Fourth row does not contain single zero. Now we look at the column number 1 and 2, there is an assignment. Column number 3, there is a single zero. So make an assignment here in the third column. So when you make an assignment in a column, we have to draw a horizontal line. So in this way, all zeros are covered, but again the number of lines are 3 and it is not equal to order of the matrix. So it is not the optimum solution. So repeat step number 4. Again we have to apply step number 4. For the step number 4, we require a minimum or smallest uncovered number. Look at the uncovered number 594,647. So smallest uncovered number is 4 now in this step. So number of lines, horizontal and vertical lines, we are drawn 3, 2 vertical and 1 horizontal. Total lines are 3, which cover all the zeros, and these 3 and the number of lines are not equal to order of the matrix, which is 4. Order of the cost matrix is 4. So this is not the optimum solution. So we have to apply step number 4. The smallest uncovered number is 4. We have to subtract 4 from all the uncovered numbers. We have to add it on the intersection of horizontal and vertical line. These are the numbers 5 and 0 on the intersection. Add 4 to these numbers and do not alter, do not change other numbers. So apply step 4 again. And then step number that is cover all zeros with minimum number of horizontal and vertical lines. So before we have to apply step 4 and then step 3 again. So let us apply step 4 again. Smallest uncovered number is 4. So elements in the first column 0, 0, 0 will not change. Add 4 to the intersection of horizontal and vertical lines. So 5 lies on the intersection. 5 plus 4 is 9. Elements in the second column 1, 0, 0 will not change. 0 is on the intersection, so 0 plus 4 we get 4 here. Then elements in the third column, sub 5, 4, 4 are, these are the numbers which are uncovered numbers. So subtract 4 from these uncovered numbers. So 5 minus 4 we get 1. 4 minus 4 we get 0, 4 minus 4 we get 0. Last 0 will not change, it is on the line. Then last column, column number 4, 9, 6, 7 are uncovered numbers, so subtract 4, 9 minus 4 we get 5, 6 minus 4 we get 2, 7 minus 4 we get 3, and 0 remains as it is. Now apply step number 3. Cover all zeros with minimum number of horizontal vertical lines starting from the first row. Look at the rows containing single zero. So first row contains single zero. Make an assignment in the first row. So we have to draw a vertical line. Now look at the second row contain 2 0, third row contain 2 0, fourth row also contains 3 0. So we first look at the single zero. Now start with the column. First column there is an assignment, second column there are 2 zeros, third column there are 3 zeros, fourth column there is a single zero. So use it for an assignment in the fourth column. When we make an assignment in the fourth column, so we have to draw a horizontal line. Now again look at the rows. First row there is an assignment, second row there are 2 zeros, third row there are 2 zeros, fourth row there is an assignment. Again look at the column. First column there is an assignment, second column there are 2 zeros, third column there are 2 zeros, fourth column there is an assignment. So now 2 rows left. B and C contains 2 0, and column number X, column X and Y also contains 2 zeros. So single zero is not available. There are more than 1 zero. So this is a situation where we get alternate solution if each row and column contains more than 1 zero. In such a situation we get alternate solution. So we make arbitrary assignment now. Either we can use this 0. So when we use this 0, that means B is assigned with X. So X is not available to assign now. So C we will assign to Y. So either use this 2 0 or use this 2 0. B you can assign with the machine Y, and C you can assign with the machine X. So this assignment problem has an alternate solution. Now since there are more than 1 zeros in row 2 and 3 as well as in columns 2 and 3, we get alternate solution. The assignment problem has an alternate solution. So we will write down the two solutions. First, so the optimum assignments are solution 1, we will write. So first solution is A is assigned with W, D is assigned with Z, and now there is a choice among B and C. So B can be performed on the machine X and C can be performed on the machine Y. So X and Y. And solution 2, A is fixed. A will not change. A we have to perform on the machine W, and D we have to perform this job on the machine Z. Now there is a choice. In the first solution we have assigned this job B to the machine X. Now we will assign job B to the machine Y. So we can interchange these two we can interchange. B we will assign to the machine Y and C we will assign to the machine X. So this is how we get alternate solution. But the cost of assignment will be same. Let us first calculate this cost. A is in the first solution Wxyz, that means C11, C22, C33, C44. This is a cost of assignment here. So what is this sum? Let us see. What are the assignment cost given in the problem? This 18, 13, 19 and 0. Actually this is a dummy row where D is the dummy job. This is dummy job and we have assigned it to the machine Z. So actually this is a dummy job. That means this job does not exist, right? But we have added it so that we can apply the Hungarian method to the square matrix. So actually there are only 3 jobs and 3 jobs are performed on these 3 machines WXYZ. So what is the cost of assignment? 18 plus 13 plus 19 plus 0. 18 plus 13 plus 19. Here the cost is 18 plus 18 plus 13, 18 plus 13 plus 19 plus 0. This is a dummy assignment. This assignment is dummy. And in the dummy row, we have assigned a 0 cost of performing this dummy job on each machine. So add this, what we get 18 plus 18, 36 plus 37, 37 plus 3, 40, 40 plus 10, 50. Now here let us calculate the cost. This assignment, first assignment is as it is. So cost of performing job A on W is 18 as it is, and D is also as it is. Now we will change in the second solution. B is assigned to Y. What is the cost of performing B on Y? Cost of performing B on Y is 17. So let us take this cost, and cost of performing C on X. C on X is 15. So 18 plus 15, 18 plus 17 is 35, 35 plus 5, 40 plus 10, it is 50. So we get same assignment cost. So there is an alternate solution for this problem. So this is an unbalanced problem, and for this assignment problem, alternate solution also exists.